Hello, good kids at the castle. Welcome to a new year. It is time for a new lab. Today, we are going to conquer the lab called How Efficient is Your Chemical Reaction? Determining your percent yield. So, what we're going to do today, and the gist of what today is going to be about, is going to be about the idea of seeing a chemical reaction take place. Then, once figuring it out on paper, being able to determine what I theoretically could yield from this thing in perfect conditions. On the other hand, around me right here is the lab. Oh no, not perfect conditions. And it's me, Mr. Knowles! So it could not possibly be perfect yet. Well, maybe, possibly. But anyway, let's see what goes down. All right, as we begin, our directions tell us to mass out 0.1 grams. For your calculations, you will be using 0.12 grams of aluminum foil. Notice initial observations: shiny, glimmering, luster, solid, silvery. All right, now that I have transferred the aluminum foil into my 50 milliliter beaker, I have taken the liberty already of measuring out our concentrated copper 2 chloride solution. And I am going to pour in. What we should start seeing at one point in time is chemical reactions taking place. We should be seeing some bubbles. Color is changing. Let's come back later. As we are waiting for our aluminum to dissolve and singly replace with our copper 2 chloride, I would like to show you the initial observations of our copper 2 chloride. As you can see, we have a clear and turquoise, baby blue colored solution. Now, what I'm going to be doing is, after the aluminum has finally dissolved, I've taken a piece of filter paper that was just a circle, and I push it into a funnel. And so, what I'm going to do is, once this is fully dissolved, I'm going to pour the liquid and the precipitate, the solid that is in there, floating in there, into this filter paper. And then I'm going to go through a process of decanting, where I'm going to take water and I'm going to start rinsing that thing through and through and through to get the filter paper to catch only the solid and let all of the liquid filter and drain out through this funnel. All right, so now it has started to, or finally has, filtered out the liquid solution. So what we are left with is a lot of this stuff right here. We have to go through this process of where I am doing a series of washing to get and aggregate all of that product that I collected and try and get it into the middle. Because ultimately what I'm going to do is I'm going to filter out this paper, or I'm going to take this filter paper, pardon me, and I'm going to dry it out, and then I'm going to mask this thing out. And so I'm going to go through a series of situations where I keep over and over and over again repeating washing this thing out. And I as well did that for this too. When I was trying to get all of the solution out, I made sure that I took all of my H2O and then I put it into that and tried to get every little bit of that product that was solid formed, every little bit of that out. so I can see how efficient this actual reaction was, and I can mask this out. All right, people, here we are. Time has passed, and we have collected our sample. Now, what you'll recognize is, or what you'll see, is that we have this orangey reddish kind of substance that has been collected onto our filter paper. Our numbers are 1.17 grams on the scale with the filter paper and the copper. Now, the filter paper itself, when I masked it out before I started the lab, was 0.83 for its mass. So you are going to have to determine then what is the mass of copper that we actually grabbed. Now, that being said, we have to also think about the reaction that was taking place, right? And we have to think about the idea of percent yield. Some of the questions at the end of the lab are starting to ask these backup ideas of saying, if we know that a chemical reaction has happened, what are the supporting evidence or pieces of evidence that we see that we can rely on to say, okay, we think that this is what's going on. In this scenario with our copper 2 chloride reacting with our aluminum, what we ended up seeing at the end, if we went back in that video when we were dumping everything out, was that the actual solution itself wasn't all the way clear. And the bluish turquoise color in the copper 2 chloride is due to the presence of copper 2 ions. And so what that then tells us, if we still have blue solution in that water and not all of that color has changed, well, then that must mean that there is still, or there still are, those copper 2 ions present. And so that at that point must mean then that when reacting with the aluminum had completely reacted and there was still more CuCl2 to be reacted with. Other pieces of evidence as well, we've seen color change, we saw bubbles, there was fizzing, there was a hissing going on. And so at that point, we knew that this chemical change happened and we collected our gas. We collected our metal, copper. And at that point, we now need to figure out how much do I think I could have theoretically yielded? And what did I actually get? By doing your calculations, you should get an actual yield now of copper. And what we want to do is we want to take the actual yield and divide it by that theoretical. What would it be in perfect conditions? And then we want to multiply that by 100. And that will show you guys, this class, Mr. Knowles' source, or well, Mr. Knowles' percent yield, how well I did. Now think about the idea of different kinds of error. Different kinds of error could be, I could have waited not long enough to have the paper dried out. And when massing the paper, there could have been extra weight. I could have had little silvery chunks of aluminum that hadn't reacted with all of that water. If you saw me, I was like trying to push that stuff down to make sure that it came in contact with all of that. There are a number of different kinds of things that could alter my data. Even using a different scale that could be calibrated differently would change my data. Right? And so there are different reasons for why I could get a lesser amount. But the gist really is that we aren't under perfect conditions in any given laboratory situation. And so there is always going to be an actual yield and a theoretical yield. And from there, we can determine how much we could get. And the reason why this is so important is if I actually can figure out that I'm actually going to get only half of that particular substance, but I wanted to make a full 100%, and I know what my actual yield is going to be. And if I'm going to only make 50% of it, and I know that, then I can double all of the amounts to get the right amount that I want. And that concludes our lab.